All right, what's up? Okay, so let's do this. I want to try and make this as quick as possible. So let's jump straight in. So we're going to talk more about symmetry today. So for now, I'm just going to have you memorize these rules or work on practicing these rules. Tomorrow, I'm going to talk about why those rules are the way they are. So for x-axis symmetry, we're going to replace y with negative y and check for equivalent equation. I'll talk about that in a second. For y-axis symmetry, we're going to replace x with negative x and check for equivalent equation. And for origin symmetry, we're going to replace both x and y with negative x and negative y and check for equivalent equation. So I apologize, there's not enough space to squeeze those in there, but these are supposed to be like in here. Okay, and then this worksheet was missing. This should have been given. So that should have been typed up. I don't know, maybe it just didn't print on mine, but hopefully it printed on yours. Okay, we already talked about intercepts, so I'm actually not going to show the work for intercepts on this because I want to keep this video as short as possible. So take 2 minutes and find the intercepts. Okay, let's practice the symmetry because that's something we have not practiced. So we want to check, we'll go through all 3 of these. So let's check x-axis symmetry, which means we want to replace the y with a negative y. Everything else stays the same. And then we want to look and see if that is equivalent to the original. Well, no, of course it's not. We just replaced the y with the negative y. One trick that you can do sometimes, not always, we'll see it later, is if I multiply this equation on both sides by -1, sometimes it will end up being the same as the original. If I multiply this by -1, I end up with a y, but then this side gets all mixed up. That would be a negative instead of a positive, that would be a positive instead of a negative, and so on. So this one does not have x-axis symmetry. Let's check for y-axis. So for y-axis symmetry, we replace all the x's with negative x's. And then let's just PEMDAS it. Let's just go through from left to right. There's nothing to do with the y. So let's look at this. This would be negative x times negative x times negative x times negative x. So negative, 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 right? So these two together make a positive, and these two together make a positive, and then a positive times a positive is a positive, right? So that ends up being positive. Now, look at this. Think PEMDAS. Am I going to do the multiplication or the exponent first? Okay, exponent, right? So I'm going to focus on the exponent. I'm going to do negative x times negative x, and that's going to make positive x squared, with a -8 hanging on for the ride. And then the -9 didn't have anything going on. Every time, excuse me, every time we're checking for equivalent equation, we're simplifying and then we're looking at the original and comparing them. So are these the same? Yep, that one has x-axis symmetry. And then for origin symmetry, we're going to replace both the x and the y's, or I said that backwards, didn't I? Both the x's and the y with negatives. And then this, there's nothing I can do there. That's just negative y. And we already simplified this. We said negative x to the 4th. When I simplify that, that's all going to become that. And now I'm in the same spot I was here. Right? If I want to make the left side the same as the left side, I have to multiply by a negative. But whatever I do to one side, I have to do to the other side. If I multiply that by a negative, it doesn't match. And if I multiply that by a negative, it doesn't match. And if I multiply that by a negative, it doesn't match. So that's a no. So the only thing this has is y-axis symmetry. Okay. And then this one, again, hopefully it printed on yours. It didn't print on mine, but we want to graph y equals x to the 3rd. So the first thing we're going to do, so here's steps to getting a good graph. We're going to find the intercepts. So to find the x-intercept, we're going to replace Good. Y equals 0. So 0 equals x cubed. And then to undo an exponent of 3, I take a cube root, right? A cube and a cube root undo each other. And then what times itself equals 0? Well, the only way to get 0 was 0, right? So now let's think about this. We have 0, 0 is our x-intercept. Could I have another y-intercept? If I have another y-intercept, then this is not a function. This is something that we'll talk about. But remember the vertical line test? I can't have a graph pass through a vertical line twice. It won't be a function. So I'm not even going to bother checking for the y-intercept because I know that a graph can only have one y-intercept, and that is already 1. So let's check symmetry again. This one will be faster. X-axis symmetry, I replace y with a negative. And I have the same problem I had before. If I multiply both sides by a negative, it doesn't match the original. So that's a no. Y-axis symmetry, I'm going to replace the x with a negative. And negative, 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 right? These two make a positive, and then a positive times a negative is a negative. So that's that. That doesn't match the original. So that's a no also. And then origin symmetry. Replace both the x and the y. Always simplify first. Always think PEMDAS. So we already did this guy over here, right? And then it doesn't match the original. However, if I multiply both sides by a -1, I end up with the original. So this one does have origin symmetry. So what does that do for me? I'll show you in a second. We did the symmetry test. Now let's do a partial graph. So let's pick some easy numbers to plug in for x. If I plug in x equals 1, what do I get for y? So 1 cubed is 1. If I plug in x equals 2, what do I get for y? So 2, 8. And then we talked yesterday about what origin symmetry does. So basically the x and also we see it here too, right? So the x and the y both get replaced with negatives. So this point is 1, 1. Origin symmetry tells me that that is also on the graph. And then we also had 2, 8. Origin symmetry tells me that that is also on the graph. So then there's my graph. So finish using symmetry, that's what that step 4 meant. Finish using symmetry. And then just a little note about the homework. So remember, you are not doing this assignment tonight. You are going to work on this in class. All right, see you guys tomorrow.